last name was off the board, so they didn't affect anything.
I see.
Guess based off that. And then Brant and Sean were the two left, and they could fit in either spot that I had them, so I had to ask other people, like, do you know who either of these people are and which photos of this is?
I see.
So I figured it out from that.
Math and effort. All makes sense. All right. What numbers did we do?
In 7.2, we did 24 to 36.
Oh, that's right. I forgot we started there. 24 to 36, and then well, let's just start with that, and then I'll ask again on the next one.
Circles first?
Yes, circles first.
Oh, here we
Bree left home, so apparently she's feeling well enough. Just running late. All right. Oh, so many pages because so many graphs. 24. All right. So 24 is, oh, it's not even graphing anything. All right. 24 is quantity x plus 3 squared plus quantity x minus 2 squared equals 16, and it's a circle. 26 is x minus 4 quantity squared plus 8 times quantity y plus 7. It's a parabola. 28, quantity x minus 4 squared plus quantity y minus 3 squared equals 64, and it's a circle. 30 is quantity x plus 3 squared over 10 plus quantity x minus 4 squared over 25 equals 1, and it is an ellipse. 32, no. What did we do, just through 30, or did we go?
32, 34, 36 as well.
Okay, great. 32a is x squared over 2,304 plus y squared over 506.25 equals 1. 32b is approximately 42 feet on either side of the center along the major axis, and 32c is approximately 84 feet. 34 is where we have pictures, 34 and 36. Didn't I turn it on? Did it turn it off? Did it turn itself off? That's annoying. I turned it on with plenty of time to spare so that we could find it in time. There it goes. Hello, connect. Oh, there it goes. Photos. 34. Is that guy? Let me turn this around. What's up, Aiden? How's life? Great? Great. 34 looks like that, and 36 looks like that guy. So, what questions on this lesson before we look at the next lesson? 30. What's up, Bree? How you feeling today? For the most part, alive. That's good. 30. I'll leave that on because the next lesson's indubitably has pictures as well.
What is the direct definition of that word?
Indubitably?
Without a doubt. Indubitably. It means without a doubt.
It does.
Without a doubt.
My dad's favorite
I
word.
searched that up one time.
Did you? That's funny.
Because I like that word.
Number, we didn't do 20. What number did you say?
30.
30. Well, that makes more sense. 30. 30. All right, we got 5x squared plus 2y squared plus 30x minus 16y plus 27 equals 0. We're about to start conics in Algebra 2 after they take their rational functions and relations test on Thursday. All right, so this is either a circle or an ellipse or a hyperbola, right? It's not a hyperbola, we know, because we hadn't gotten there in the book at this point, but it's one of those three because x and y are squared. What should we do?
Group the x, blank space, and move 27 over to the right.
Great. I'm going to rearrange and move the 27. So 5x squared plus 30x space 2y squared minus 16y with another space equals negative 27, right? Wow. We can take a 5 out of the first chunk, right? 5, and then we're left with x squared plus 6x. And we'll take a 2 out of the next one, plus 2. So we're left with y squared minus 8y with a space equals negative 27.
It's a, an ellipse, because they're different.
Probably, yeah. Yeah, it's almost certainly an ellipse. Okay, so we're going to find the completion of the square. 6 divided by 2 squared is 3 squared is 9. So we're going to add 9. And then over here we've got to add 9 times the 5, right? So plus 45, right? Right.
9 times 5.
Yes, because of this one, right? Yeah. And then this other one, we've got the negative 8 divided by 2 squared, so negative 4 squared, so 16. So we've got to add 16. And then over here, we've got to add 16 times 2, so 32. So on the left side, we factor these, and we'll factor into the middle one. So we've got 5 times x plus 3, quantity squared, plus 2 times y minus 4, quantity squared, equals, yep, I agree. Divide everything by 50.
Even though this way we know it's an ellipse, but still just to get the alternate.
Right, because we want it to be a 1. Yeah, it's definitely an ellipse. We want it to be a 1 because we're supposed to write it in standard form. But yeah,
How do you know it's an ellipse?
because this and this are different. If they were the same, it would be a circle.
Okay, and if, now we know if it's a parabola.
If only one of them is squared, right? So if either just this is squared, just this is squared.
I can make that up.
And if this was a minus, then it would be a hyperbola.
All of those wrong. That's okay.
Okay, so we're going to divide everything by 50. Right? So we end up with x plus 3 squared over 10. Right? Plus y minus 4 quantity squared over 25 equals 1. And it's an ellipse. It's a ellipse. What direction is the ellipse? It's a vertical or horizontal ellipse? It's a vertical ellipse. And it is centered at negative 3, 4, right?
Can we do 32?
I bet we could.
It's a word problem.
Did you try it?
I did.
Good.
Failed miserably.
Good. That's okay. We don't mind failed miserably as long as we tried first. All right.
I tried a word problem, but I'm just not great at them.
That's okay. We start where we start and we get better, right? That's always the goal. The United States Capitol has a room with an elliptical ceiling. This type of room is called a whispering gallery because the sound is projected from one focus of an ellipse, reflects off the ceiling and back to the other focus. The room in the Capitol is 96 feet in length, 45 feet wide, and has a ceiling that is 23 feet high. All of this is true. You can, if you want to spy on people at the Capitol and listen to a conversation across the room, you stand over here while they're talking over here, and you can hear them. It is cool and a little crazy. All right, so write an equation modeling the shape of the room. Assume that it's centered at the origin and the major axis is horizontal. So just to have something to scribble on, we're talking about a shape that looks more or less like this. Right? And then we are told, let's see, 96 feet in length. This is 96 feet.
What number is this?
32. And 45 feet wide. So this one is 45 feet. And the ceiling is 23 feet high. However, we don't care. But if we were designing the dome, we would care, but we don't care. Write an equation modeling the shape of the room. All right, so
It's an ellipse.
it is an ellipse, and it's centered at the origin, so the numerators are going to be x squared and y squared, right? Because we're not plussing or minus anything, right?
Yep.
And we know it's going to equal 1. We're off to the races. So what we need to know is what is a squared and what is b squared. So we need to know what is a and what is b, right?
Okay, so it's horizontal. The major axis is horizontal.
Yes.
So that'd be
The 96th one goes with the b,
that
right?
means it's a horizontal ellipse, right?
Yes.
Okay. Let me check it out. So then A goes with X. So 96 goes with X.
96 goes with y, because it's the longer one. 96. You need to like update your notes or something or whatever else, because or think about it different, because it's got the long one goes with Oh no, you're right. You're right this time. Long one, yeah, it does go with X. Yes, it goes with X. You're right. I apologize. Yes, because that direction is at left and right is X. Did you know that, Garrett? I didn't know it for like 2 minutes apparently. Okay, great. Yes, that X does A is yes. Great. Now what?
So do we square 96?
Well, how does it relate? Like, what is the essentially formulas that we're using for that?
I don't know. Is it the H plus R minus A? Because we know what.
H plus or minus A.
Because we know what the
Yeah.
points are with some math, so then we just.
So we're looking for the vertices and the co-vertices.
Kind of, yeah. We're not really looking for them. We're looking for what goes underneath here.
Okay, so we know the whole length is 96, but so we're gonna have to divide it in two in order to figure out what the plus and minus is. 48.
48.
So A is 48.
Yep, and so to find out what goes there, we square that, right? 48 squared is a whole heap.
2,304.
Yeah, that's exactly what the book says.
2,304.
Yep. So, to find the b in this case, the one that goes with the y, right? We divide that by 2.
So it'll get us 22.5. And then if you square that, it's 506.25.
So then the answer to part A is x squared over 506.25 plus y squared over. This time, let me write it. This time it was vaguely intentional. Over 2,304 equals 1. Oh, no, it wasn't vaguely intentional. The order of the x and the y was intentional.
Do you need that, Sean?
Apparently. Apparently so. Yeah. What I was gonna say doesn't really apply in quite the context. But on an ellipse, it doesn't matter whether you put the x or the y term first, even though the book writes it both ways, depending on horizontal or vertical or whatever else. But these numbers do have to be underneath the correct variable. That is still true too. Great, there's part A, and then part B is whatever part B is. What is part B?
Find the location of the two foci.
Yeah, so you would, that's easy enough, yes? You would do 48 and then, oh, the foci, just kidding. LOL. What's the foci formula?
H plus or minus C.
H plus or minus C and then K, right? So we need to find C. How do we want to find C for an ellipse?
Square root of A squared minus B squared.
Yes. Square root of A squared minus B squared, right?
So that's about 42.4.
That's probably true. C equals about 42.4, and you would add that to 0 and subtract that to 0, and so plus or minus 42.4 and 0 for the foci. It's just 0. Yeah.
And then, how far from one focus would one have to stand to be able to hear the sound reflecting from the other focus?
So it would be double that, right? Because so this is the focus-ish. And so it's this distance. So it'd be this one doubled.
52.4 times 2?
42.4.
84.4.
Mm-hmm. Feet, in fact. Yeah. So not too bad, just kind of understanding all the puzzle pieces and putting them in the right place and all the things. They also, because word problems like to do this in math books, they also throw in a number that's irrelevant to this particular problem.
Ah. And that was the Z?
Yeah, that was the this distance. If we were, like I say, we were designing that dome, we would need that information. But we are not designing that dome. All we want to know is where can I stand so I can spy on that guy over there. That's all we're trying.
Architecture class, Sean?
No. No. I'm not gonna teach architecture or structural engineering. Neither one of those classes. Because those are two very different classes. Architects are like, oh my gosh, look at this awesome, crazy thing with this overhang, and then they give it to the structural engineer and say, you figure out how to make it work.
I see.
It's a little more nuanced than that, but that's kind of the meme.
Make things out of boxes.
They dream and then the engineers do.
Yeah, kind of. There's obviously quite a bit. The architects do have to do some engineering too, but it's not quite the just, I draw pretty pictures, you make the thing, but that's kind of the meme. Yes? Great. Let's look at hyperbolas.
Hyperbole.
All right, what do we do on these? A whole heap, right?
2 to 28.
2 to 28. Great. All right. More pictures. I'm selling things on Saturday. Y'all should come out and check out the things I'm selling.
At the,
It's at Connect Church. It's a craft fair.
Are you selling scrunchies?
All right, that is one of the things I am selling, yes.
What else are you selling?
Selling some bags and some coasters and probably some planter boxes if I am able to make them this week. And headbands. That's horrific. Hold on. Maybe that's better. That's better. Great. Hooah! There is number 2. He looks like that.
no gracious.
Oh, gracious, he says. And then number 4 is up here somewhere, right there. Number 6 looks like that guy. And 8 is this one. I don't know why they didn't draw the asymptotes on that one, but there's number 8. Okay, and then number 10 is there, and 12 is next to it. And 14 is right there. And 16 is that guy. And 18 is this one. $20 is this one. $22. Oh gracious! Did you do this homework, Garrett?
I did.
You did.
Yeah.
Oh.
I told you before class I left it at home.
Oh, that's right. That's right. I remember you did,
I was
but
angry boy.
that's right. You were angry boy, and that was why. I do remember now. 22 is right there. 24 is quantity x minus 1 squared over 36 minus quantity y minus 5 all over 64 equals 1. 26 is quantity y minus 6 squared all over 9 minus quantity x plus 1 squared all over 49 equals 1. 28 is quantity x plus 4 squared all over 144 minus quantity y minus 7 squared over 25 equals 1. And 30 is quantity y plus 5 squared all over 19 minus x squared over 36 equals 1. Did we go, what did we go through? 32?
28.
Oh, 28. Well, then why am I still reading? Okay. So, what questions on those? 12.
I lost paper. I ran out of paper, so now I have to use this crap.
So, do we need to get you some more paper? We can get you some paper.
I normally use this kind of paper, but I ran out of regular notebook paper, and this notebook paper is like
Terrible.
1,000 years old. And it's see-through.
Oh.
All right, number 12 says, graph the hyperbola given by the equation x plus 5 squared over 9 minus y plus 4 squared over 48 equals 1. Okay, so what clues tell us that this is a hyperbola other than the fact that this is in the hyperbola lesson?
Subtraction in the middle.
Subtraction in the middle, both things squared equal 1. Yeah, great. So, what things can we glean from this?
The H and K and the A and the B.
So
What are the
the
instructions again? Sorry, I wasn't paying attention.
I asked what we can glean from this. Graph it is the instructions.
Okay, cool.
Is that what you were talking about? What you meant? Yeah. Where's the center?
4.
Negative 5, negative 4.
Because everything's in the parentheses is opposite.
Yep. That's great. So the vertices would be useful. Right? So how do we find the vertices?
H plus or minus A.
So negative 5 plus or minus 9. No.
The square first.
Which direction is this opening?
This is horizontal.
No, it's left and right. It's a horizontal hyperbola.
Okay. How do we know? What are we looking for?
Because it's x minus y.
Because it's x minus y. So since it's x minus y, this is opening which way? Horizontal. So it's this and this. So we are moving the x to find the vertices. So I was not wrong, but I needed to stop and make sure we were doing things right, right? So the y part is going to be negative 4. And this is going to be negative 5 plus or minus 3, right? How do we get the 3?
9's square root.
Square root of 9. So negative 5 plus 3 is negative 2. And negative 5 minus 3 is negative 8. Okay, so it's got vertices there and there. And then really there's only one more thing that we really need to find, one more set of things that's useful to
Asymptotes?
yeah, graph it. That's what the words I'm trying to say. So, asymptotes. We're using point slope form, right? The point being the center, right? So y minus negative 4 is y plus 4. How do we get, what is the slope of the line? How do we figure that out?
Plus or minus, for this one it's going to be b over a.
Plus or minus b over a. And b in this case is which one?
40, square root of 48.
Yeah, square root of 48. So square root of 48, which unfortunately is not particularly even, is it?
That's right about 7.
It is right about 7, which is what we'll use over 3. And x minus negative 5, which is plus 5.
Hey, it's square rooted. Y.
Because these, remember, this is a squared and b squared. Mm-hmm. Right? So square root of 48 is about 7. Right? So it's going to be y plus 4 equals plus or minus 7 over 3 and x plus 5. Right? So now let's graph it. So our center is at negative 1, 2, 3, 4, 5, negative 1, 2, 3, 4. So here, which we only barely care about. Well, no, I guess we do care about because that's how we draw the asymptotes. Yep. So, and then our vertices are negative 2 and negative 1, 2, 3, 8. So our vertices are right there. So from the center up 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. So about right there.
So the x plus 5 doesn't affect anything?
That's, what do you mean it doesn't affect anything? What it does, if that's, so let me get this on here so I can think and talk, not try to think and talk and write all at the same time, because we've already determined that that's a struggle, yeah? Okay, so when you're graphing something in point slope form, point slope is y minus y1 equals m times x minus x1. So that's point slope form, which is what we're given the asymptote equation in, which makes sense because we're referencing everything about this hyperbola graph off of the center of the hyperbola, right? And so x1, y1 are a random point, and the signs flip because of the minuses, right? And so typically when we graph something from like slope-intercept, we start at the y-intercept, right? And then we count the slope. In point slope, we start at this point, the x1, y1, right? So the point, negative 5, negative 4. And then we count the slope from that point instead. So it's just a different starting place, way to start the line. Yeah. So that one, and then we go down 1, 2, 3, 4, 5, 6, 7 over, what, 3, right? 1, 2, 3. And then connect those dots. And we've got asymptotes. And then we follow the little pattern we've drawn for ourselves and do the best we can to draw the hyperbola. Up that way, yeah? More or less that.
Can we do 26?
Probably. Number 26. Is that a, yeah. Okay. So, we are supposed to write an equation for the hyperbola given some characteristics about it. Wait till you take Cal 3 and you start taking conics and spinning them around, making 3D shapes. So much fun. So we are given that it has foci at 9, 7, and negative 17.
Wait, are we doing 26?
Yeah, right in that. Oh, I'm writing. Oh, you want? Oh, that's sad. I don't get to make the comment that I was gonna make, but that's fine. 26. You said 26 or 28?
I'm fine with either.
You're fine with either.
No one.
Well, 28 is harder, right?
Let's do 28.
Let's do 28. Great. Like I said, it has foci at 9, 7 and something, negative 17, 7. And it has asymptotes. Oh, interesting. Asymptotes at y equals plus or minus or minus 7/5.
No, it's 5/12. I got confused as well. That's the next problem.
Oh, that's funny. 5/12
104/12.
x plus, we don't even care, but 104/12. Well, we might care. There is a way we could use it to figure out things, but we care more about the slope, TBH.
So is this just point slope form?
That's slope-intercept form.
Yeah, slope intercept.
Yeah, it is.
We can still use it, right?
Yeah, yeah. We might need it. It might be helpful. Because see, the thing is, we're gonna need our equation to be useful. We're gonna need it in point slope, but there are infinitely many point slope equations to define a line. So we want a very specific point slope. So what can we determine from this information?
We know K is 7. And
We know
that
K is
it's
7.
a horizontal hyperbola.
True. This is a horizontal hyperbola, and K is 7. Because K is consistent. So, see if we can find the center, because that would probably be very useful, right? So a center at something 7, right? What is halfway between 9 and negative 17?
Wait, 4?
Right? Just the average of those two numbers. So negative 4? You were on the right track. All right, we got a center. We got a slope. We can write, we may or may not need it, but we can write the specific, we can rewrite this as the correct point slope form. May or may not be helpful, probably, well, it may or may not, right? So the correct point slope form would be y minus 7 equals plus or minus 5/12 times x plus 4. It's the same equation, right? May or may not be helpful. In fact, it's not helpful, but just throwing it out there. All right. So this is a hyperbola, and it's opening left and right. So it's going to be x squared minus h, no, x minus h squared over a squared minus y minus k squared over b squared equals 1. That's what we're going for. We know h and k, right? So we know that it is x, excuse me, plus 4 squared over a squared minus y minus 7 squared over b squared equals 1. So what we need are what are a and what are b.
We know C equals negative 4 because, no.
We don't, you could head down that route, but there's an easier way, right? We have the center and we have the foci. We just need the distance from here. We just need the plus or minus this way, right? So to get from negative 4 to negative 17, how many we got to go? Or negative 4 to 9, how many do we got to go? 13. 13. True enough. So that gives us one of those, right? Does it give us the A or the B? It gives us A. So 13 squared is what? So is it 13 or is it, because the book says it's 12.
I have a question. Can't we just get there because we have the 5/12?
Oh yeah, we can. Yeah. Yeah, we can. Yeah, because, yeah, duh. Because 12, that's B over A.
Oh, right.
Look at that. That's great. So this squared and this squared. Beautiful. We did it.
Okay, that makes more sense now.
We just use the puzzle pieces to find and know where we're going, right? To find the missing ones. It's honestly the same kind of thing as problems back in the day, where it's like, okay, find the equation of the line slope intercept that goes between this point and that point. It's the same thing. We just start shoving stuff in until we have enough pieces to have what we want at the end. You, of course, can. Let us look at rotations of conics. Get to throw a little trig into our conics.
Is this still 7.3?
This is 7.4, rotations of conic sections, which will be the last lesson that we cover in this unit, which means that we theoretically, actually, we will either have a test a week from today, so next Tuesday, or I am suspecting more likely a week from Thursday is my suspicion. And then, is it vectors or polar coordinates? Vectors. Then we get to do a little bit of vectors.
This is 7.4.
This is 7.4, rotations of conics. Yeah. Okay. So, when we're thinking about rotating conics, it is best and easiest to think about rotating everything. Okay? It's easier to think about it that way. So, in fact, it's easier to think about, instead of thinking about, if I've got an ellipse that looks like this, more or less, give me a second or so, this and this and this one and this one. We got that ellipse. If I want to think about, okay, how do I rotate that? It is, if I want to rotate it 30 degrees, it's easier to think about, okay, now I'm going to rotate my entire axis 30 degrees. Right? So what we typically do when we do a rotation is we draw an x prime, y prime axis that's been rotated that many degrees. And then the parabola stays, not the parabola, I drew an ellipse. Then the ellipse stays the same, but on this new axis. So you draw the same ellipse, but crooked. Right? And that is how we think about it. And we start rotating things degree measures. There's a trig function for that, right? So we're going to start chucking some trig into our ellipses and hyperbolas and parabolas and all the things. So now, not only can we have vertical ones and horizontal ones, we can have oblique ones, which means slanted, right? Makes sense? Easy peasy? How we doing so far? A little nervous?
Maybe a little bit.
Okay. So, if we want to find the new equation in the new plane and write the new equation, we do it using this formula. How you doing, sir? Good. We haven't hardly done anything yet. Easy peasy.
What the formulas?
Oh, yeah? What did you come up with?
Not a lot.
Not a lot.
I know it's gonna have probably an H and a K and an A and a B, maybe.
H and a K and a B and all the things. Huh? Yes. So, the equation in the x prime, y prime plane can be found using this formula. X equals x prime times the cosine of theta minus y prime times the sine of theta and y equals x prime times the sine of theta plus y prime times the cosine of theta. And theta, of course, is the angle of rotation. Okay. How are we doing so far? Let's do an example.
Great.
See if we can put some skin on his bones. I promise that you don't really have to use any identities to speak of. We're going to use theta equals pi over 4. Oh my gosh, I can't write.
Do you want it in radians or do you want it in degrees?
Well, it's given in radians. We're going with radians.
So we don't have to, like, convert it.
What?
We don't ever have to convert it. Just do what it gives you.
We want it in radians.
So if it gives it to you in degrees, convert it.
Yes. We're going to use that to write (6x squared) plus 6xy plus 9y squared equals 53 in the x prime, y prime plane. And identify the conic. All right, so the clue that this is a conic turned sideways is all the squares happening and this, and also the way the problem's written, right? X times y, it gives us a clue that, okay, there's something that this is some sort of conic and it's turned sideways. If it was a circle turned sideways, then it's still a circle. That's fun. So this is quite difficult to graph. Now we could, if I was just to say, don't do all of this and graph it, you would start shoving numbers in for X and solving for Y and connecting a bunch of dots and being like, okay, this is probably a this, right? And that's like, you can still graph it, yes? It would just be, of course, after doing this problem, y'all might think it's also tedious and ugly, but you know, whatever. Okay, so we need to find some information, right? So we need to figure out, we need to use the formula we just did to find X and Y. Sound good? So, what is the formula for X that we just wrote?
X equals X prime times cosine of theta minus Y prime times sine of theta.
And Y is X prime times the sine of theta plus Y prime times the cosine of theta. Does that seem accurate, or did I make a mistake?
You put Y is Y prime.
I made a mistake, but a tiny one. All right? So, what's the cosine of pi over 4?
I know this.
Oh my gosh, we have to go back to that thing.
Is it, hang on, what's the answer supposed to, no, like, what kind of thing is it?
It might have some square roots in it. It's going to be a fraction.
Square root of 2 over 2.
Square root of 2 over 2.
Yeah, because it's the same on all of them.
What?
It's the same on all of them.
What? Okay. So, X equals X prime times the square root of 2 over 2 minus Y prime. What's the sine of pi over 4?
Also,
Square root of 2 over 2. And Y equals X prime times square root of 2 over 2 plus Y prime times square root of 2 over 2. Now, that's kind of a mess, right? And, well, it's a little bit of a mess that we could clean up a little. How could we clean those up a little?
I mean, if you divide everything by square root of 2 over 2, then you'll have X divided by square root of 2 over 2 equals X prime.
That's true.
Prime.
I was just talking about shoving it, making each one of them one fraction. But yeah, you could do that. You absolutely could do that. So X, we could rewrite slightly, ever so slightly simpler as X prime times the square root of 2 minus Y prime times the square root of 2 over 2 and Y as X prime times the square root of 2 plus Y prime over the times the square root of 2 over 2. So now we can shove those into that to get our equation in the X prime Y prime axis. Let's do that. And then we shall graph it if we're very lucky. So 6 times X times the square root of 2, or X prime, excuse me, the square root of 2 minus Y prime times the square root of 2 over 2, quantity squared, plus 6 times X prime times the square root of 2 minus Y prime times the square root of 2 over 2 times X squared, no, X prime times the square root of 2 plus Y prime times the square root of 2 over 2 plus 9 times X prime times the square root of 2 plus Y prime times the square root of 2 over 2 equals 53. Oh, quantity squared equals
I messed up
53.
so bad.
Uh-oh, what happened?
That was just
All right,
big enough.
we got to do a little cleanup. I hope you've been practicing your binomial squared theorem because that's going to make your life a lot easier. But if you have not, you'll have to factor this all out. Okay. All right. So, using the binomial squared theorem here,
What is the binomial square?
a squared plus 2ab plus b squared. So, times x prime squared times 2. Let's just write that as 2x prime squared minus two times this plus this, 2 times x prime times the square root of 2 times y prime times the square root of 2. What's square root of 2 times the square root of 2? Square root of 2 squared, so 2. So times 2 times y prime plus 2y prime squared all over 4. We have a conjugate on the top. What happens when we FOIL conjugates? All we have to do is full, right? First and last, right? Because the outside inside is always going to cancel, right? So we've got the minus, same thing with different signs in the middle. 6 times the first, x times square root of 2 times x times square root of 2 is x squared times 2, right? So plus 2x prime squared. And then the last, negative times positive negative, so minus y prime times y prime is y squared. Square root of 2 times square root of 2 is 2. So minus 2y prime squared over 4. We got another binomial squared. So plus 9 times the first one squared is 2x squared. And then 2 times this times this times this. Square root of 2 times square root of 2 is 2. 2 times 2 is 4. So 4 times x prime y prime. Well, that's this squared, which would be the same as it was over there. Plus 2y prime squared over 2 squared, which is 4, equals 53.
What the heck?
It's just, we just like combine stuff here, just distribute them.
From the 6? Or from the number set?
No, you're combining the two things, so like you're multiplying the 2 inside the parentheses, and since the 2 on the outside are squared, remember there's 2 of them.
Okay.
Remember that if you're doing a plus b squared, it's a squared plus 2ab plus b squared, right? That's a shortcut. You do not have to do it that way. It's just going to say, but if you don't do it that way, then you have to do a plus b times a plus b, which is going to take even more space. But you can do it that way if you need to.
Okay.
All right, those are all over 4. We can shove those into one fraction, right? And we can also distribute stuff, right? Actually, what we can get rid of fractions right now, right? Multiply everything by 4 and get rid of fractions. So multiply everything times 4. Get rid of the fractions and then go ahead and distribute all the stuff. So 6 times 2x prime squared is 12x prime squared. This is this right here is -4. -4 times 6 is -24. So -24x prime y prime. 6 times this is plus 12y prime squared. 6 times, probably could have divided everything by 3 as well, actually. That's fine, we'll do that in a second. 6 times this one is 12x prime squared. 6 times this one is -12y prime squared. 9 times this one is 18x prime squared. 9 times this one is 36x prime y prime. 9 times this one is 18 y prime squared, and then 4 times that is 212. Does that sound right? Everything is at least divisible by 3, except maybe that other side. No, it is.
It's not.
Oh, no, it's not. You're right. It's not. Okay, so what do we do now?
Divide everything.
It's not divisible by 3. We'll wait on that. How about we combine like terms?
Oh, gracious.
So,
12x prime.
x prime squared and x prime squared, y prime squared and y prime squared. There's another x prime squared and another y prime squared. We also, have x prime y prime and x prime y prime. So 12x prime squared plus 12x prime squared is 24x prime squared. Negative 24x prime y prime plus 36x prime y prime is plus, what, 12, right?
Yes.
12x prime y prime. And then 12 minus 12 is 0, plus 18 is 18. So plus 18 y prime squared equals 212. We got different numbers somehow. They're all divisible by something. 2, oh, maybe we didn't end up with different numbers. They're all divisible by, is this divisible by 6? 3, 4, 5, no, it's not. But they're all divisible by 2, at least, right?
Yeah.
We still ended up with different numbers than they did. We may have to pause and come back. 12, because we probably made a mistake. 12x prime y prime. You're just what?
Don't hit to divide by. No, we can multiply by 4. I'm confused with myself.
106.
You don't have to do this. You know, you make the rules.
Yeah, we still ended up with some sort of mistakes because they have a, well, or they have a mistake, but they have that this is a 21 and this is a 6. So we're already past time So we're going to put a pin in this and finish it up next week.
Pinned.
Okay. Which means definitely not have a test a week from today. It means at the earliest it'll be a week from Thursday.
Thank you, Sean.
Mm-hmm.